What is going on, guys? Welcome to your, let's see what tutorial it is, ninth? I think it's our ninth physics tutorial. And in this tutorial, now that we know the importance and how we understand the need for sig figs, we can go ahead and start using them in our scientific notation problems. So what I did is I went and grabbed a couple problems from tutorial 5 and tutorial 6. And back then, whenever we were working with scientific notation, we didn't know about significant figures. And by the way, I don't know if I mentioned this, but sometimes I call significant figures sig figs just because it sounds cool. So anyways, now that we know about sig figs, we can go ahead and solve these problems again, and we're going to solve them correctly this time. So what we need to do is go ahead and solve these problems again. So 6.71 times 10 to the 3 times 2.3 times 10 to the 5th power equals 6.71 times 2.3 times, and I might skip a couple steps here, 10 to the 3 plus 5, which is 8. So basically what we have is 15.433 times 10 to the 8th. So in our last tutorial, or not our last tutorial, tutorial number 5 I think it was, our final answer was 1.5433 times 10 to the ninth power. Now you're saying, alright, that answer looks pretty correct to me, but we need to consider the rules of sig figs. So in order to do that, when working with scientific notation, we need to look at how many digits are in the least accurate number, or coefficient as they're properly called. The coefficient is the number that's not the one with the exponent. So basically what we're going to be doing is saying, alright, this number has 1, 2, 3, and this number has 1, 2. So remember in the last tutorial when I was talking about how our scales had different accuracies? Well, pretend that we're measuring these with scales right here. This scale would only go to the tenths place, and I just changed my color to red, and my text is red. This scale only goes to the tenths, and this scale goes to the hundredths. So basically we can only use an answer that goes to the tenths. So basically our correct answer would be 1.5, and I got 1.5 from rounding 1.54 times 10 to the ninth. And again, the reason for that is because we can't just go ahead and include these numbers because we don't know for a fact that this is 2.3000. So we can't claim to have more information than, we just can't make up information like that because our equipment wasn't that accurate whenever we got this data right there. So let me go ahead and give you guys one more example, and I need to change my color again. So actually, let me go ahead and get out my piece of paper right here for my tutorial. Make sure I'm working with the right problem. So 7.62, yeah, that's going to pop up. And by the way, I think whenever I make my YouTube videos, they always try to, let me see if I can get it. Oh, it won't even do it now. But they always put the thumbnail as whenever that box pops up, and it's really annoying because it looks like I'm making a mistake on all my videos, which I kind of am, but do you guys know what I'm talking about well, never mind. Again, I'm just rambling. I'll stop doing that. So let's go ahead and solve this problem. I'll shut up. 7.62. Again, we're dividing, so we have to put divide by 2.1, and then we go ahead and multiply that by 10 to the third divided by 10 to the fifth. So let's go ahead and solve both sides of these equations. 7.62 divided by 2.1 equals 3.629, and we need to go ahead and multiply that, and I'm just going to go ahead and skip a step here. 3 minus 5 equals negative 2, so that's 10 to the negative 2. So we go ahead and basically in our 6th physics tutorial, we said that this was the final answer right there. However, now that we know about significant figures, let's go ahead and take a look at this data up here. This one only goes to the 10th of one place, and this one goes to the 100th. So basically, our answer can only go to the 10th because that's our least accurate piece of information right there. So what we need to do is we need to round this answer to the nearest 10th. So 3.6 times 10 to the negative 2 is our correct answer. That's what we should have had because, again, like I said, this data right here, we don't know for certain how accurate that is. We only have the equipment to measure to the 10th, so that's what our answer should be right here. So now that you know the importance of significant figures and also basically saw those examples in real life examples, what the heck am I talking about? Well, anyways, now that we saw that in practice, we can begin to move on to something else. However, there are a couple different rules that I think I better tell you guys before, jump into mass and physics and atoms and electricity and stuff like that. So definitely check out the next tutorial. And if you guys have any questions about sig figs or physics at all, I should probably mention this in the last couple tutorials. Make sure to check out my forum at thenewboston.com/forum, and you can ask me questions there, and I will be happy to answer them for you guys. So anyways, thank you guys for watching, and don't forget to subscribe, and I will see you in the next tutorial.